Lawrence, since your mother has now shared with me the actual problem that we were looking at on Friday, I figured that I would explain it using the exact problem that we were doing Friday. So if you look at this particular problem, this was the graph that they asked. They asked you to get the domain and range of the inverse function. Now, the domain and range of the actual function, so this being the absolute function, is pretty basic because we can read it right off the graph. We know that horizontally it goes from -6 to positive 6, so that is your domain. Vertically, it goes from 3 down to -5. That's the farthest it goes down, and 3 is as high as it goes up, so that would be your range. So if I write that down, I could say that f of x, the domain of f of x, looking at the picture, like I said, it goes from -6 to +6. So all the points fit within -6 and +6. So writing that in interval notation, that's going to be -6 to 6. The range doesn't go all the way from +6 to -6. It actually, the farthest it goes down is -5, and the highest it goes up is 3. That's why I put these numbers in here just to make it easier, so you could see it rather than have to count your way up. So my range in this problem goes from, if I go from the lower to the higher number, goes from -5 to +3. So all that you really had to do in this particular problem that was given to you on your test was to, for the inverse function, all you have to do is just invert your domain and range. So what was your domain for the function will be your range for the, so the domain here will be the range down there, and the range here will be the domain, if you're just talking about the inverse function. So for the inverse function, so I guess I'll write domain inverse of x. That's going to equal -5 to +3. And then the range for the inverse function is going to equal -6 to 6. So you've got the function and you've got the inverse function. Now, when I was explaining how to get the function, or how to do this, which is more work, but it's something that you may have to do in another problem, is they could ask you to actually graph the inverse function. And just knowing the domain and range isn't really going to help you write the inverse function. So what I need to do is I need to get the inverse function. Now, there's two ways of doing it. The way I showed you, I said to break this into two piecewise functions. See, that's a line equation with a slope of 1. That's a line equation with a slope of -1. I can break it into that this is the function between -6 and -2, and then this is the function between -2 and +6. So we could do it that way, and that's the way I was showing you the other day. And then once I know those two functions, I can just I can switch my x and y to get the inverse function. But there's another way of doing this. If I happen to have noticed, and I didn't when we were doing this the other day, this is an absolute value function. Because an absolute value function, let me pull it up here. I had it ready to go. The absolute value function looks like this. So this is the absolute value function. Well, you can see that there's a similarity between this function and this function. The difference is this is a v that's concave up, and this is a v that's concave down. Another difference between the two is that the vertex, the bottom point here of this, is at 0, 0, and the vertex point of this is at -2, +3. So this, if I were writing what this function would be, I'll do it in red, this function is simply the absolute value of x. Now, I want to transform this into that. So the first thing I'm going to do is flip it over so that instead of the v being like this, the v is down here. And I can do that by simply putting a minus in front of the absolute value. So you can see here that in the original formula, if I have 1, 1, 2, 2, 3, 3, well, by putting a minus, when I have a 1 for x, I'm at minus 1 for y. When I'm at 2 for x, I'm at minus 2. So it's just going to flip this over so it's down there. But I also need to move the vertex of this. So to do that, the next step would be I'm going to still have the minus, the absolute value, but to shift it to the left, I'm going to add 2 to the x. That actually, by putting in plus 2, that will shift this 2 to the left. Now, not only do I have to go 2 to the left, but I have to go up 3. I need it to be right there. So I'm just going to add 3. And what I have on the board now, that actually is this right here is what that function is. Without breaking it into two functions, it's now all one function. I don't know whether it's going to be any easier to do it this way as compared to breaking it into two piecewise functions, but it is another option. So we know that if I wanted to get the inverse function, which might be something that I want to graph, then what I would do is, first of all, we know that the f of x means that's a y. So I can write this over here as y equals minus x plus 2 plus 3. And if I want the inverse function, we know the rule is just switch the x and the y. So I'm going to get x equals minus the absolute value of y plus 2 plus 3. And if I want to, now I want to solve this for y. So the first thing that I need to do is I need to move the 3 over and the minus over. The 3 has to come over first. So when I bring it over, I'm going to get x minus 3 on the left side. When I bring the minus over, it's going to change the signs of both of these. So instead of x minus 3, it's going to be minus x plus 3, and that will equal the absolute value of y plus 2. Now, absolute value is a little bit tricky because there are two different answers that can go in here that are going to give me this. Let's look, for example, let's say if it was just 3. Let's say 3 equaled this. Well, I know that there's two answers here that equal 3. The absolute value of 3 equals 3, and the absolute value of minus 3 equals 3. So this choice and the negative of this choice are the two options in order to solve this. So I'm going to get minus x plus 3 is going to equal y plus 2. So that's one option. And then the other option is going to be minus x plus 3 is going to equal minus y minus 2. That would be the negative of whatever is in there to begin with. So, for example, if this thing equaled 5, if that's 5, then I also need minus 5 as a choice. So think about it. For this to be 5, y would be 3. So you can see 3 plus 2 does equal 5. If I put a 3 in here, I get minus 3 minus 2. It's still, absolute value of minus 5 would still equal 5. So these are the two choices that I have. Now, I just want to solve each of these for y. So let me move this stuff out of the way. And so if I solve the one on the left for y, I'm going to get y equals, so I want to get y by itself, so I need to move the 2 to the other side. So when I move it to the other side, I'm going to subtract 2 from both sides. So on the left here, I get minus x plus 1. That would be if I simplify the equation above. And the other one, y equals, now in this one, what I'm going to do is I'm going to move the y to this side that makes it positive, and I'm going to move these two to the other side. So I'm moving the y over there, that makes it positive. Now when I bring a minus x to the other side, it's going to be plus, and when I bring the 3 to the other side, it's minus 3. So minus 3 minus 2 is minus 5. So these are my two equations. If I want to know where the vertex is, I can really just make this side equal to that, and that will tell where it actually, because there is one point on both of these that is common, and that's the vertex, the vertex point, which, let's show that again. The vertex point is this point right there. So I can see that it's minus 2. It's at minus 2 comma 3. So if I want to find that point, I can make minus x plus 1 equal to x minus 5, because that means that the y's would be equal where those two are equal. And solving this, let's see, I'm going to move the minus x, I'm going to move the minus x over here, and I'm going to move the minus 5 over here. So when I move the minus 5 over here, I'm going to be adding 5. So 1 and 5 is going to be 6. So I'm now going to have 6 on this side. When I move the minus x over there, I have to add x. X and x is 2x. And so that means that x equals 3. So, oops, okay, so actually, x equals 3, that is going to be, because that was the inverse function that we just did, x equals 3 is going to be the vertex angle of the inverse of this function. So I can get that by, if I want the full point, then I can either plug in 3 into this equation or 3 into that, and I should get the same answer. So you can see, if I plug a 3 in there, minus 3 plus 1 is minus 2. If I plug a 3 in there, 3 minus 5 is minus 2. So the vertex point is going to be at x equals 3, y equals negative 2. And once I have that, I can then, well, let's actually put them in. Well, actually, I'm running out of time here, so I better shut the video off. But, there's a lot that you can do with this stuff. And I don't know whether you've done transformations, but if you haven't done transformations, this is really how they're done. So what I just solved here, this last thing that I just solved, would be the vertex point of the graph up here. So if I were to go 3 to the right and 2 down, this point right there is the vertex point of the inverse of this other graph here. So there's the vertex point of the function. The inverse function's vertex point would be right there. So it's probably going to go in that direction and in that direction. In fact, it probably goes from here all the way to 6, and from here all the way to negative 6 vertically. And horizontally, it's going to go from, we can see here horizontally, it's going to go from negative 5 to 3.